So, last class I have finished plate load test. Now, next field test is your standard penetration test. So, it is a well established method, particularly investigating soil properties for the preliminary design. Generally, it has been used to measure relative density of granular material, allowable bearing pressure by means of correlations, pile capacity, friction angle of the sand. Basically, it gives value of N, penetration resistance N. With respect to N, then phi can be find it out, then liquefaction potential of granular soil. So, the test is made by dropping a free falling hammer. If you look at here, there is a first you have to do a borehole, up to that depth you do a borehole. Then inside the borehole, with the help of drill rod, you insert split spoon sampler inside, then there is a drill rod and there is a anvil and there is a drop hammer. Generally what happen, free falling hammer of weight 63.5 kg, it is 63.5 kg, IS code said 65 kg, onto a drill rod up to a height of 76 or 75 centimeter, and number of blows required to penetrate last 30 centimeter is recorded as N values. Suppose this is your drilling rod or drill rod. Now you allow by means of a SPT, you raise this hammer and drop it, and you mark the scale here 15 centimeter, then another 15 centimeter, then another 15 centimeter. Total you are going to do 15, 15, 30 plus 15, 45 centimeter of your penetration. Generally first 15 centimeter of penetration has been left. Why? Because it is carrying up about your any kind of sitting load or unevenness of the soil, or because you are making a borehole here. So, it is not possible to give the exact value of your N value properly. So, that is why first 15 centimeter has been discarded. So, that is why last 30 centimeter recorded as the N values. So, what you are supposed to get it, this is the N, SPTN, this is your depth. So, if I say this is my 0, 2 meter, 4 meter, 6 meter, then I am supposed to get this kind of this diagram, SPTN values for last 30 centimeter of your penetrations, and this is about your split spoon samplers. Detailed dimension has been given here, it is a split spoon samplers. So, it will penetrate inside. This is about your how the split spoon sampler details, you can see it, pipe sampler tube and split spoon samplers. Split tube sampler, it has been written here. Then so hammer comprise of hammer, mechanism that lift and drop the hammer. It consists of anvil, system and anvil or drive head. Actually energy depend on the skill of the operator, smoothness. This is your visual inspection, you can visualize, means last few lectures I am showing it by drawing the diagram. Here is your photographs, you can see how it is a continuous process. One side borehole has been made and same site, same process, one borehole has been made, you can do the SPT, also you can collect your undisturbed soil samples. So, there are two corrections, basically two corrections required. One is your overburden correction and second is your dilatancy corrections. This I am going to discuss in detail. Correction for your hammer system, what you are doing hammer, if you look at, generally this is called N60, it is your NF, means whatever your penetration resistance N1, N2, N3, N4, N5 and N6. N1 is your energy correction factor, N2 is your rod length correction factor, N3 is your liner correction factor, N4 is your borehole diameter correction factor, N5 is your anvil correction factor, N6 blow count frequency correction factor. These all corrections has to be added before reporting your N value, it should be N corrected. Now let me start with this. So as per Terjagi and Peck 1967, so why you are measuring the penetration resistance for particularly granular soil, if I take it granular soil, that means cohesionless soils. So one hand I am putting it relative density, then N is your blows per 30 centimeter, then angle of shearing resistance phi, then degree of compactness. So 0 to 15, 15 to 35, 35 to 65, 65 to 85, greater than 85, and blows you are supposed to get 0 to 4, 4 to 10, 10 to 30, 30 to 50, and here you are supposed to get 50. Phi value is varying 28 degree, 28 degree to 30 degree, and 30 degree to 36 degree, and 36 degree to 41 degree, and here it is your 41 degree. Now very loose, then is your loose, then medium, then dense, then very dense. This is for your granular soil. Now if I come to your cohesive soils, then I can put it consistency one hand, then undent shear strength Cu, then N. Very soft, medium, stiff, very stiff, hard. Cu is your, generally it will be ton per meter square, generally it will be 0 to 1.25, 1.25 to 2.5, then 2.5 to 5.0, 5.0 to 10.0, then 10.0 to 20.0, then greater than 20.0, then blow supposed to be, you are supposed to get 0 to 2, then 2 to 4, then 4 to 8, then 8 to 16, then 16 to 32, and it is 32. Standard penetration test is basically for cohesionless soils or granular soils, and it has been extended for C5 as well as cohesive soils. If you look at here, what parameter I am supposed to get it? If blow count is, if my SPTN after first, second and third blow count 30 centimeter is 0 to 4, what does it indicate? It indicate it is a very soft, very loose soil, and its phi value will be 28 degree or less than 28 degree. If it is between 30 to 50, that means it is very dense soil. Phi value is 36 degree to 41 degree. Once I am getting the n value, I am supposed to get phi, I am supposed to get its relative density or the compactness. Similarly, for cohesive soils, once you get the n value, from n value you can say that whether it is soft, very soft, medium, stiff, very stiff or hard soils, and depending upon your undent shear strength you can range is given in ton per meter squares. Now come back to, as I said, after hammer correction is over, there are two corrections. One is your overburden corrections, second is your dilatancy corrections. If overburden corrections, first is your overburden corrections, generally n corrected Cn into Nf. So, n corrected based on your overburden pressure and Cn is your correction factor, Nf is your n value obtained from the field, it is from the field, and Cn is your correction factors. So, you can follow the as per your Bureau of Indian Standards, they have given, you can download it, Bureau of Indian Standard, they have given a chart for particularly Cn corrections. Here it is varying from 0.4 to 2.0, and P effective overburden pressure kilonewton per meter square, it varies from 0 to 500. The correction is coming about to be in this range. So, once you know a particular depth, suppose you are making a borehole, why overburden corrections? Any logic? Because what happened? Initially the ground is a level surface. What happened? You do a borehole, that means you are taking out the soil samples, then measuring penetration at this depth. While measuring penetration at this depth, the entire overburden has lost. That is why this overburden correction is required. For particularly this depth at 2 meter, gamma into h, which is equal to what is your density into h, find it out effective overburden. Once you know the effective overburden, from there, from the chart you can get correction factor Cn. There are many corrections available, there are many correlations available given by Peck and others that you can see, but best way you follow the chart from your Bureau of Indian Standard, from there you can find it out your overburden corrections. Second is your dilatancy correction. Dilatancy correction is recommended saturated fine sand and silt. It is recommended for saturated fine sand and silt to counter, particularly to counter negative pore pressure. Once there is a water table, if there is a fine sand, so what will happen? There will be a kind of negative pore water pressure. To counter that, this correction is required for dilatancy. If it is a saturated fine sand and silt, then only your dilatancy corrections required. Remember, dilatancy correction followed after your overburden corrections. You cannot do dilatancy correction first, then overburden. First overburden corrections, then is your dilatancy corrections. So, it is only possible after overburden corrections if n corrected is greater than 15 after overburden corrections, then finally after your dilatancy correction 15 plus 0.5 into n corrected minus 15. This is your dilatancy corrections, provided look at the two conditions. Dilatancy corrections will be followed after your overburden corrections, and if after overburden correction if n corrected from overburden is greater than 15, then only your dilatancy correction, it is n is equal to 15 plus 0.5 n corrected minus 15. So, there are many correlations available, directly you can get it phi value from your n corrected. Now, one of these has been given by Halankar and Uchida 1996. So, phi is equal to 20 n corrected CR root over plus 17 degree, it is in terms of degree. Also you can find it out E value. Let us discuss this phi. You can get correlations, from this correlation you can get the phi. So, generally recommended you increase by 5% phi value for soils, for soil containing less than 5% silt. Whatever phi you are getting, you increase 5% for soil containing less than 5% silt. Now, what else I can get it? I can get the modulus of elasticity E from the n value. E is equal to C1 plus C2 into n, the unit is your kg per centimeter square. So, now how the value of your C1 and C2, how these things are going on. So, C1, C2 values are depending upon this C1, C2 values, I will give it to you. C1, C2 are functions of typical type of sand, C1, C2 are typical type of this sand. So, Bowell's 1988 he has given some kind of correlations. So, type of sand, then E kg per centimeter square, sand NC, NC is your normally consolidated soil. So, in this case E is equal to 5 into n plus 15, then sand saturated, in this case it will be 2.5 n plus 15, then sand over consolidated, it is your 7.5 into n plus 24, then sand with gravel. So, this will be 12 n plus 6 for n greater than 15 and 6 n plus 6 n less than 15, then silty sand, it is your 3 n plus 6. So, these are the correlations has been given by them, particularly to get the value of your E. You can get the C1 and C2 value from the Bowell's book. I will give it next class what are the generally C1, C2. So, C1 plus C2 n, this is widely used, and Bowell's 1988 also given typical type of sand, for that what is the value of a E. Once you get n corrected, once you get it, then from there you can find it out what is the value of your E. E is your modulus of elasticity. Then there is another test that is called DCPT. Its full form is your dynamic cone penetration test. It is called DCPT. It is a quick test. What happened? There is a rod, at the end there is a cone. So, drill rod, this is called drill rod, there is a cone, generally 65 kg of your hammer at a height of 75 centimeter. You can say that this is your 75 centimeter and this size is 65 kg. The way you do it for SPT, so 65 kg of hammer, free fall at a height of 75 centimeter. So, you can measure every 30 centimeter what is your penetrations. So, what is the advantage of DCPT rather than SPT? In SPT what you are doing, there are advantages as well as disadvantages. If you look at SPT, in SPT what you are supposed to do, you first in SPT first make a borehole. Suppose up to 2 meter you make a borehole, measure your penetration resistance N, collect undisturbed soil sample in the same borehole, then again you make the borehole, it is your 2 meter, this is your 2 meter, up 4 meter, then do the SPTN, collect undisturbed soil sample. So, in this case advantage is, in SPT advantage is, this is your SPT, this is your DCPT, dynamic cone penetration test. SPT advantage is you are doing two things. One thing is your measuring penetration value, from there you can get a phi, right. At the same depth also you can collect undisturbed soil samples, from undisturbed soil sample you can get engineering properties of these soils. This is the advantage. Disadvantage is, in this case you are making a borehole, the cost will be slightly higher side. In DCPT what you are supposed to do, this is your ground surface, in this ground surface advantage is you are not doing any borehole, you are only putting in the drill rod, putting a cone at the base and doing the penetrations of a 65 kg of a hammer, free fall of your 75 centimeter or 750 mm, you are measuring every 30 centimeter what is the penetration value. So, basically at the end the cone will be there, once you are going you can go down. So, here you are saving a price, kind of you are not doing any boreholes and you can go up to any depth. In this case it will be very difficult going for a borehole at a deeper depth. In deeper depth it will be very difficult to borehole because water will come into picture and loose soil will be there, it will be very difficult. So, both has merit as well as demerit. Once you get DCPT, what is the correlation between DCPT and SPT? If I write it, N dynamic cone, DCPT, dynamic cone penetration, what is the value of the N every 30 centimeter is equal to 15 minus 2 into N corrected. This is your DCPT and this is your value SPT. So, once you know it, then you will be knowing what is the value of N corrected, that is from the SPT. I will check this correlation, there are other correlations also available, I will check the correct one, I will put it. So, basically once you are getting a DCPT, you can from the correlations you can find it out SPTN value. Once you get the SPTN value corrected, from SPTN value corrected you can find it out your value of phi. Once you get the phi value, from there you can find it out your relative density. Once you get the phi value, then this will taken care, this will be helpful for your foundation design. This is most popular. This is most popular in India, particularly SPT and CPT. CPT is your cone penetration as well as DCPT. So, I will show you some of the PPT form, I left it earlier. So, overburden corrections and dilatancy correction. As I said, so dilatancy correction will be followed by your overburden corrections. That means, first you have to do your overburden corrections, you cannot do your dilatancy corrections. Again, after overburden correction, if n is greater than 15, then only you can go for dilatancy correction. These are all your rod length corrections. The many correlations are available. You see now here it is there, sand, normally consolidated, all the value correlations are available. You can get it by means of Peck 1974. If footing is there, n value is there, you can directly find it out your bearing capacity. Now, another advantage of this SPT, another new thing has come into picture, that is your unit skin friction from SPT. Unit skin friction can be obtained by rotating the SPT split barrel sampler after it is driven into the ground up to the standard penetration test. Once it has been inserted, once you have done the standard penetration test, then it can be rotated. You see here you rotated by apply the torque, then calculated recorded maximum torque, then from the torque you can find it out your frictional resistance or unit skin friction. Fs is equal to 2T pi L d square. T is your measured maximum torque, d is your outside diameter of split barrel sampler or split spoon sampler, outside diameter of this, then length of the penetrations, total length of your penetrations. So, length of the penetration will be, we are measuring last 2 30 centimeter, last 2 15 centimeters, that means it will be penetrated first 15 centimeter, then 15 centimeter, then 15 centimeter. So, length of penetration will be 45 centimeter. From there you can get unit skin friction. Once you get unit skin friction, where it will be utilized? If you go for pile foundations, there are 2 types, 3 types: friction pile, end bearing pile, friction as well as end bearing pile. In friction piles, it will be resisted by means of your frictional resistance. Once you get this skin friction, you can directly go for a pile foundation design of this. There are different case studies. Unit skin friction has been observed by 12 sites across the US to evaluate unit skin friction measurement obtained from SPT and values. So, what are the limitations? SPT is subjected to many errors which affect your design. SPT value is not appropriate for determining or to find it out allowable bearing pressure of fine grained cohesive soils. It is not appropriate. Reliability of the test for obtaining different dynamic properties of soil like seismic velocity, shear velocity must be checked. Testing should be accomplished in several borings in varying soils. Energy measurement should be done on a periodic basis, and that the effect of wear and tear on the equipment is being considered. Now, last class I have finished the plate load test by showing your diagram, by plotting the diagram. Now, it is a visual. If you see this, how it has been done. Look at here, this is your test pit, this is your plate, this is your plate 300 mm to 700 mm, this is a hydraulic jack, and this is your reaction beam. Above the reaction beam, load has been applied so that it should not be uplifted, and now you apply by means of pressures. So, loading system may be 3 types. Gravity loading system. Gravity loading system means you apply by means of sandbag, so that load has been applied to the reaction beam by means of your gravity load, only gravity load. Reaction loading system, That means this reaction frame will be anchored here by means of piles. So, then this loading system will not be there. Then there is a truss system. By applying truss system you can apply. Then look at here, as I said here, dial gauge here, dial gauge here. I can show a photograph to you. This you can see it. This is a truss system. Here we carried out at IIT Kanpur, truss system, loading system, and there is a pit. Inside the pit, plate load test has been carried out. See, different types of curves you are supposed to get it, yesterday I said. From nature of the curves, you can slightly say that what kind of soil it is. Look at here, if it is moving this way, then change linear up to here, linear, non-linear, non-linear, again here asymptotic. So, this case it is a dense cohesionless soil, that means it is a kind of general shear failure. I will come back what are the different types of failure. Then look at a slightly non-linear, then it goes again linear, partially cohesive soil. Another one is after linear all of a sudden it become asymptotic, it is a cohesive soil. Then there is a straight line, loose to medium dense cohesive soils. This whatever you are getting, load versus or pressure versus settlement from plate load test, from these graphs it gives an indication what kind of soil, possibility of what kind of soils are there. Look at curve BD, curve B, put a tick mark, D here. Curve BD, soil's failure is well defined. Yes, it is well defined. I can plot a single tangent or double tangent, from there I can find it out ultimate bearing capacity. But in case of curve A and C, this is your A, this is your C, yield point is not well defined. Where yield point is not well defined, where you are getting a kind of a straight line, in that case you plot it logarithmic scale, log scales, then we will get approximate value of intersections here and here. In such cases load settlement curves drawn on logarithmic scale, the plot gives two straight line and the intersection of which gives the bearing value, the intersection of which this is giving your bearing values. This I have already discussed. This part subgrade modulus I am not discussing. Once I will start the foundation design, how it is coming, there is in detail I am going to discuss it. There are also plate load tests, there are also cyclic plate load test. Cyclic plate load test of loading and unloading, why you are doing it? The test simulates traffic conditions by repetitive loading. Loads are applied in cyclic manner, that means loading and reloading. It establishes the progression of accumulated deflection due to both elastic and permanent deflections. Cyclic loading you are doing it, you find it out what is your elastic settlement as well as permanent, basically elastoplastic behavior of the soil you can get it, permanent deflections. Load cycle curves gives bearing value of any particular deflections, determination of deflection modulus and bearing value for particular deflections. How you are supposed to get it, how the graph looks like, typical load settlement curve, cyclic, loading, unloading, look at here. Suppose you are giving a 20 ton per meter square or 10 ton per meter square by means of your hydraulic jack, loading, bring it back to 0, then reload it, then again loading, unloading, reload, cycle 1, cycle 2, cycle 3, cycle 4, cycle 5, it will continue. Now, if you look at here, this is the value of your phi, you can get it. Now, from there you can find it out what is your, if this is my things, elastic and permanent deflections, I can find it out what is the elastic deformation as well as permanent deflections or deformations, that I can get it from here. This is where I want to stop it. Next class I will start it cone penetration test as well as permeability. I will go slightly faster because this course basically a foundation design, this part as a preliminary what are the tests, then we will go to our real foundations how it has been designed. Thank you.